No worries. Yeah. Good evening, children. So once again, we are meeting for our NEET and JE questions for physics. Last class 11th we had looked at different questions based on every topic chapter wise na வந்து discuss பண்ணிருந்தேன். Now today we are again going to continue with different types of questions. Now as Sir has also told that we are going to do previous year question papers as well as mock papers. Test series also we are planning. So I will be sharing physics question papers also. In case if you're interested, definitely I would recommend you to give as many as papers. So நீங்க எவ்வளோ papers நீங்க solve பண்றீங்களோ that much you will have a wide variety of knowledge. That types of questions can come from what kind of chapters. So that is very important. So I'm having so many question papers with me, mock question papers for upcoming NEET examination 2024. So feel free. I will also send it. Instead of putting it in the group, I will send it to sir. Sir, when so you can plan it out one by one, questions as and when it can be conducted. So you can give the tests.
Yes,
And you
Manish,
can
I will do that. I will do the needful.
so that will be very useful. Fine. So now we will continue with the questions. So here is one question. So randomly I have picked up different types of questions, and I thought this is important. So we'll discuss one by one. So here's the first question. So putting a dielectric substance between two plates of an isolated condenser, capacity, potential, and potential energy. So capacity அப்படிங்கும்போது they are talking about capacitance, which is given by the letter C. The SI unit of capacitance is in farads. Okay, and potential அப்படிங்கும்போது it's nothing but the potential difference, which is measured in volts, and potential energy. So potential energy is again measured in joules, which has the symbol U. Sometimes it is also referred as PE in short. So when a dielectric substance is inserted, what can happen to these three physical quantities? In the monophysical quantities, what will happen? Whether the quantities will increase or whether they will decrease is the question. So this is the basic outline of the question. So now, who can tell me what is a dielectric substance? If a dielectric substance, if we are going to introduce in between two plates, two charged plates, what are the possibilities? So you can tell me, you can start answering. Don't put on chat box. I would recommend you guys to verbally unmute and then speak. Okay? Yeah. So any idea?
Sir, transfer of charges will reduce, sir.
Yes, so the reason use the transfer of charges will reduce. Okay. So now dielectric capacitor when the insert பண்ணும்போது what will happen? What happens to the capacitance of the capacitor? நீங்க எல்லாருமே parallel plate capacitor பத்தி படிச்சிருப்பீங்க இல்லையா? So we have learned it. So what happens to the capacity when a dielectric material is inserted between its plates? Any guesses? No idea? Very simple. When we learned capacitance chapter 2 in grade 12, so we understood that whenever a dielectric material is inserted between the plates, the capacitance increases. Now, why does it increase? See, you have two plates. One positive plate and inner plate is negative. How do I understand which is positive and which is negative? It all depends on how I'm going to do my battery connections. So if I'm connecting like this, you can see that the positive terminal is connected to the right side plate. I will name this as plate A and this as plate B. So there are two metallic plates. Okay. So I'm connecting here a simple cell along with a key. You can see that plate A is connected to the positive terminal, wherein plate B is connected to the negative terminal of the cell. So plate A will be positively charged and plate B will be negatively charged. Now you can all see that there is a gap between the plates. Okay, so depends on the amount of potential that you're applying by the cell or the battery. So the plates are going to conduct each other, and there is going to be an electric field that is being set up between the plates of the capacitors. Okay, so we all know that current flows from the region of higher potential to lower potential. So we learned that in electricity chapter. So you know that current flows from positive to negative. So I am showing the direction of current. Okay, same way electric field is also being set up in this direction. So electric field is also going to be there from which is facing from plate A towards plate B. Now what happens to the capacity of this capacitor? In the capacitor I have not introduced any dielectric material. So when there is no dielectric material, say its capacitance is C. Okay, so it is. I'm just giving it as C. Suppose I'm going to introduce the dielectric material with some constant dielectric constant K. This capacitance get enhanced by K times. It becomes K times C. So there is a difference by introducing dielectric material between the plates. So whenever you have a dielectric material, the capacity of that capacitor is going to increase. So this is very important. Okay, so we can easily say that after introducing dielectric, capacitance has increased, therefore its capacity will also increase. Now we will go by the method of elimination. எப்போவுமே whenever you have options which are closely related, it is better to go with the method of elimination. So here you look at the options very closely. In which options for capacity they are telling it is increasing. Let us eliminate the wrong ones. Option 1 says increase. So this is correct. Option 4, option 3 is also telling you increase. So this is also fine. Okay, as of now it is okay. So we have two options which we feel is right. Option 1 and option 3. So now we have to decide between 1 and 3. So இதுல எது wrong அப்படிங்கறத நம்ம decide பண்ணி அதை eliminate பண்ணணும். So we have to eliminate that. So how do we do that? So for that we understand we need to write down what is the formula for capacitance of a capacitor having dielectric material with say with some K which is inserted between its plates. Okay, so what is the formula for capacitance of a conductor? We all are aware. Yeah, somebody is trying to tell. So Sundaresh, you can tell if you know it. What is capacitance
Cube,
for? Huh?
cube, sir.
Okay, so it is, we can write it as epsilon naught A upon D. This is the general formula. Epsilon naught வந்து permittivity of free space அப்படின்னு சொல்லுவோம். Okay, இப்போ because there is a dielectric material inserted, so it becomes K times epsilon naught A by D. Okay, so this is the formula. Now, what is the formula for potential of the capacitor of a capacitor? Potential na V. Capacitor symbol C da. So, which is the formula that relates C and V? Anybody? Any idea?
Q equal to CV, sir.
Very good. We all know that charge is equal to C times V, where C is capacitance and V is potential. So, இப்போ நமக்கு இங்க potential தான் கேட்டிருக்காங்க. So, let us isolate it. Potential வந்து subject ஆக்கி rearrange பண்ணுங்க. So, you will get V is equal to Q upon C. Is it clear? So, V is equal to Q upon C. So, what do you understand from this equation? Potentialக்கும் capacitance-க்கும் இருக்கக்கூடிய relation என்ன? They are inversely related, right? Which means if potential increases, what happens to the capacity? Will decrease. Okay, so that is what we understand. So therefore here potential, if capacity increases, then potential will decrease. So we have understood capacity will increase by introducing a dielectric medium. So capacity increase aganonna, what should the potential do? The potential should be less, it should decrease. Are you understanding? So that should be less. So potential has to be less. So that is what we try to understand. So எங்க decrease இருக்கு? First optionல, second பாத்தீங்கன்னா decrease. Third optionல increase சொல்லிருக்காங்க. That is wrong. You understand? Potential has to decrease. It cannot increase. So which is the correct answer? The correct answer is option 1 or option A. சரிங்களா? So by using the method of elimination, we can eliminate the wrong answers and we can find out the relation. இப்போ anyway we have இது வந்து நம்ம guess பண்ணி கரெக்ட்டா சொல்லிட்டோம் answer. What about the third quantity, that is potential energy? அதுவும் பார்த்துடலாம். So potential energy is given by the symbol U. And what is the formula for energy? Generally, what is the energy formula for potential energy for a capacitor? யாருக்காச்சும் தெரியுமா? The formula for potential energy of a capacitor. Any idea?
1 by 2 CV squared, sir.
ஆமா, 1 by 2 CV square இருக்கு. Okay, so you can use that formula. Okay, Q square upon 2C இருக்கு. மூணு formula இருக்கு, if you can recall. Okay, Q square by 2C, 1 by 2 CV square. So எந்த formula பார்த்து if you see, so you can see that here in this formula that capacitance is in the denominator, right? So Q square upon 2C is potential energy formula. Okay, so here we are trying to relate charge and capacity. So when you're relating charge and capacity, now here you can see why am I choosing this particular formula. This formula is giving me a relationship between capacity and charge. So I'm making use of this relationship. So what is happening to the potential energy? You can see that the potential energy is going to increase, or is it going to decrease? Is it more or is it less? It will be less. Why it will be less? Because you can see that capacity is going to particularly increase. So when you say the capacity increases, இது increase ஆகணும்னா potential energy U வந்து decrease ஆகணும். That is the reason I'm saying it should overall decrease. So it should decrease. So option 1 is satisfying all the situations. So the answer is option 1. I hope it's clear, this question, to all of you. So we have looked at this question in detail. So now we'll move on to the next question. Okay. So is it clear to all of you? Shall we go to the next one? Any doubts you can ask immediately and get it clarified. Fine. I hope it's clear. So we'll move on to the next question. This is the second question. In the question pathina, it is circuit analysis. Current electricity in the question they have asked from current electricity. So here you have a circuit with a cell with EMF E, and there are resistors which are connected in series and parallel combination. They're asking you what is the EMF of the battery. So EMF means this. What is the value of E they are asking? So you have to calculate the value of EMF. Okay. So how do we approach this particular question to calculate what is the EMF? So first, to find out the EMF, you have to reduce the given circuit. So total circuit to be first reduced. So how can we reduce the circuit? Anybody? I want you guys to try and tell me what is the effective resistance of this particular combination. So reduce it fully, and then we can find out what is the EMF. Or you can also find out, apply the loop laws and find out what is the current passing through the resistors and find out. So any approach would be fine. Okay. So here current of 1 ampere is flowing. So they have given you one value of current. Current flowing through 2 ohms is 1 ampere. So that information we have. Having this as the basis, you can calculate what is the EMF. So branch, apply the Kirchhoff rules. So you can mark all the nodes in this given circuit. So you can mark it. So we can call it A, B, C, and D. So there are 4 nodes in the circuit. The current between node D and C is 1 ampere. So you have to branch the currents and then find out the equations. You have to frame the equations, solve the equations, and get the currents in all the branches. So that is the approach for this question. Okay. So how will we assign? What are the currents? Anybody? Any idea? எப்படி assign பண்ணலாம்? We have learned current electricity also. So anybody would like to tell me how we will assign the currents in each of the circuit? Again, it is based on the Kirchhoff laws. So the current entering node C is 1 ampere. So when current entering here is 1 ampere, you show the distribution of currents. Okay. So for that, you mark the terminals of your cell or the battery that is shown here. The terminal of the cell is plus and minus I have given. So current will start flowing from here. So let me say current I is flowing. So current I is encountering node A. At node A, current I is getting split. So say out of I1 current flows through 6 ohms. So what is the remaining current that flows through 2 ohms? It will be incoming current minus outgoing current, which is I minus I1. Okay. So out of I minus I1, 1 ampere flows through 2 ohms. So what is the balance current which will flow through 1 ohm? It will be I minus I1 minus 1, because that 1 ampere flows here. Are you guys getting me? So that is how you find out what is the remaining current that is flowing here. Okay. So once you have assigned all the currents in the branches, so now you are going to apply the Kirchhoff's law. So Kirchhoff's laws are of 2 types. ரெண்டு law இருக்கு Kirchhoff's law. Kirchhoff's current loop இருக்கு. அந்த KCL அப்படினு சொல்லுவோம். அப்புறம் Kirchhoff's voltage law. Kirchhoff's current law, Kirchhoff's voltage law. இந்த மாதிரி ரெண்டு law இருக்கு. So what is Kirchhoff's current law? The sum of the incoming currents should be equal to the sum of the outgoing currents across a node or a junction. So you can see there are 4 nodes. So sum of all incoming currents should be equal to sum of all outgoing currents. That is one. And one more is Kirchhoff's voltage law, which tells you the sum of all the potential drops inside the closed loop should be equal to 0. You can see that there are 3 loops. Let me name the loops as 1, 2, and 3. Okay. So let me try to write the equations for each one of them. for loop 1, for loop 2, and for loop 3. So we will try to write the equations. Okay. So we'll start by with the loops one by one. Okay. So for the first loop, let me write. So in loop 1, let's write the equation. What will be the equation? I will start from the 2 ohms resistor. So I'm moving in the direction of current. So 2I. Then I'm moving in the direction of current of 6 ohms plus 6I1. Again, I'm touching the negative terminal of the cell or the battery. So minus E equal to 0. This is my first loop equation. Adhe Mari, for second loop and for the third loops also you're supposed to write down the equations. So in loop 2, who can tell me the equation for loop 2? Just give it a try. Loop 2 is A, D, C, B. That loop. We will start from A to D. How many components are there? There is just one resistor component moving in the direction of current. So 2 times, what is the current passing through 2 ohms between A and D? It is I minus I1. So 2 times I minus I1. Then I am moving across 2 ohms resistor. The current is already given in the question as 1 ampere. So that is 1 ampere current. So I'm moving the direction of current. So plus 2. Then by the time I'm moving here, so what is the current that is going to flow here from C to B? That's not necessary because you don't have any resistive component there. And again, I'm coming back to point A. I'm moving in the opposite direction of current from B to A, but current is moving from A to B. So I will take minus sign. So minus sign to be taken, minus 6 times I1, and then I reached the original position. So is equal to 0. This is the second equation. Similarly, you will write the equation for the third loop as well. So in loop 3, again I'm starting from point D and I should reach point D again by traveling inside the loop. So what will be the equation? So I can say the current, the resistor is 1. So 1 times current passing through it is I minus I1 minus 1. Then again in the direction of current we move. So it is again same 1 ohm resistor only. So again this same expression I will write. So I'm multiplying this with 2. And then I'm moving in the opposite direction of the current for 2 ohms resistor. So minus 2 into 1 is 2. I came back to the original point D is equal to 0. So there are 3 equations. So we have to simplify these 3 equations. So simplify them. So first equation you try to simplify. All constant terms I'll bring it to the right side. So I can write 2I plus 6I1 equal to E. Second equation can be simplified. Club all the like terms. There is 2I again here also. There is minus 2I1 and minus 6I1, which adds up to minus 8I1. Minus 8I1. And then you have plus 2. I'm taking to the other side. It becomes minus 2. So constant terms, I'm writing it separately. Okay. So this will be the simplified version of the second loop equation. Now coming to the third loop. In the third loop, I have plus I, but entire equation to be multiplied with 2. So 2I plus 2I minus 2I1 minus 2 and minus 2 is minus 4. So minus 4 comes to the right side, it becomes plus 4. So equal to plus 4. So these are the 3 equations that I have. So 3 equations to be solved and you will find out what are the currents. And then you can finally find out what is the EMF of the cell also. Okay. So solve the system of equations. So you have system of linear equations in 3 variables. So you can see the first two, the second and the third equation. So I'll mark this equations. So say this is 1, this is 2, and this is 3. In equations 2 and 3, they are in terms of I and I1. So you can eliminate one and you can find out the other. Okay. So let's try to eliminate them. Just you can do 3 minus 2. So what happens if you do 3 minus 2? Just subtract. In case you do 3 minus 2, you will have minus 2I. Minus 2 minus would be plus 8I1 equals to plus 2. So I am subtracting them. This term gets cancelled off. Plus 8 minus 2 would give you plus 4 or plus 6, sorry. So it's 6 I1 is equal to 4 plus 2 is also 6. So I1 is equal to 1 ampere. So we got the value of I1 as 1 ampere. Okay. So having known the value of I1, you can find out what is I as well. Use one of the equations and find out what is I. Right? So the value of I would be, you can use one of the equations. So either 2 or either 3 and you can substitute it back. So what is the value of I? Anybody? Substitute it back. So you get I equals to minus 2 plus 8 whole upon 2. Okay. So minus 2 plus 8 is again 4. 4 upon 2 is 2. So you will get I as 2 amperes. So we got the value of I as 2 amperes. Okay. So I is 2 amperes and I1 is 1 ampere. So what is the value that you're getting? So 2 times I is 2 plus 6 times I1 is 1 is equal to E. So what is the value? 2 to 4 plus 6. Okay, check the equations also. So 10 volts you're getting. Okay. So like this, you solve the equations and then you find out what are the values that you get. Fine. So in the Mari equations form panni, you will have to simplify it. So for this you will have to know what is Kirchhoff's voltage law. Again, we have done this. So this law to be applied inside the circuit and then you will have to find out. Okay. And resubstitute. I hope this part is clear. So this is how you solve this. So we'll move on to the next one. Okay. So question number 21 is a different question. So let us look at it. The magnetic needle of a vibration magnetometer makes 12 oscillations per minute. So they have given you the number of oscillations per minute. So they have told that it is 12 oscillations per minute. Okay, so that data is given here. In horizontal component of Earth's magnetic field. Okay, so they are telling it's horizontal. And when external short bar magnet is placed at some distance along the axis of the needle, so they are placing it along the axis of the same line, it makes 15 oscillations per minute. Look at here, it is changing. Previously it was 12, and once it is placed at some distance along the axis, you can see the oscillations per minute change to 15. Okay, if the poles of the bar magnet are interchanged, that is north is becoming south and south becomes north. Okay, then the number of oscillations it makes per minute is, then what would be the number of oscillations that it makes is the question. Okay, so how do we investigate this particular question? So magnetic field, when they are telling you magnetic field, Earth's magnetic field or horizontal component of Earth's magnetic field, you have a formula BH. It is a representation is BH. So magnetic field is given by BH here. Okay. Now, what is the time that they have given? That is, here they have told you 12 oscillations per minute, right? So T is nothing but when they say 12 oscillations per minute. So here you try to find out what is the time component. Now, what is the time? We all know time can be written as the reciprocal of frequency, right? Here they have given oscillations per minute. Now, what is this called? The number of cycles per minute, right? Or oscillations per minute represents frequency. So they have given the frequency in the question. So using frequency, we can find out the time period. So the first one, what is the time period for the first part? That is 12 oscillations per minute. Go ahead and substitute. You will get 1 upon 12 per minute. When you have to convert in terms of per second, right? So 12 upon 60. So reciprocal, and you will get 60 upon 12. 60 upon 12 should be equal to 5, right? So let me take it as T1. So T1 is equal to 5 seconds. So we got T1 as 5 seconds. Then what are they telling? Then when an external bar magnet is placed at some distance along the axis of the needle in the same line, again they are placing it. That means now what is a new magnetic field? New magnetic field will be equal to the previous magnetic field due to the horizontal component plus the new magnetic field that you are creating by placing another bar magnet at some distance. So BH plus B. Okay. Now again you find out what is the time period for this situation, that is T2. So T2 is equal to, again, reciprocal of frequency. Frequency they have told it's becoming 15 oscillations per minute. So it is going to be 60 upon 15. So how much is 60 upon 15? I guess it has to be 4, right? So 4 times. So you will get 4 seconds in this case. So once you have got the time, now we will go ahead and we will try to find out what is the number of oscillations it is going to make per minute if the poles are going to be interchanged. Okay, so for this you need to have a different analogy. We all know that time period of oscillation T is inversely proportional to, there is a relationship, I'll tell you that, is inversely proportional to the square root of magnetic field. There is a relationship. Okay, so time period is always inversely proportional to the root of magnetic field. So we make use of this particular relationship. Okay, so when we make use of this relationship, because we have time period for both the cases, so therefore we can simply say 5 by 4. What am I doing? I'm doing T1 upon T2. T1 we found as 5 seconds and T2 we have found as 4 seconds, right? By solving, is equal to under root of BH plus B, because that is a new magnetic field. Yes, BH plus B upon BH. That is horizontal magnetic field. So I'm substituting. Simplify this. Okay, I'm going to remove the square root term. How do I do that? You can take square on both the sides. Okay, you take the square on both the sides and go for a simplification. So when you do that, what happens to this? You will get B upon BH is equal to 9 upon 16. So this is the value that you will get. Okay, 9 upon 16. I have found out the ratio now. But for the new magnetic field case, we all know that it is BH minus B, the new magnetic field. Okay, so here BH plus B is right, which we wrote. Yeah, so that is a new magnetic field when a short bar magnet is being placed. So now what we are doing, I am trying to find out when polarity is being reversed, what happens to the new magnetic field? It will no more be BH plus B. Why? Because they are telling that it is being reversed. So when we say there is a reversal, so it is new magnetic field has to be BH minus B. Then what happens to my new time period? New time period will be 60 upon, I don't know what is the corresponding value, right? The time period. So let me take it as X, number of cycles per second, right? So therefore 60 upon X, we don't know what is X. That is what we should find out. Number of cycles per unit time. So 60 upon X. So here that X value is what we should find out. So come on, let's do that. So we can now substitute the value as 5 divided by 5. Yes, so because that is the value that we found out initially. You can see T1 is 5 seconds even before reversing. So now 5 upon 60 by X is equal to under root of BH minus B upon BH, because the polarity has been now reversed. So when you reverse, BH plus B won't be used again. Okay. Now go for a simplification, children. Substitute the value and now you simplify it. Now what happens when you substitute and go for a simplification? You will get X upon 10 is equal to under root of 7 upon 16. So substitute the value that we have. We know that the value of BH here and B also. So therefore I'm going for substitution and then I'm simplifying. So upon doing this, I will get this. Then go for a rearrangement. You will all get X is equal to under root 63. So the value of X is root 63. The answer is option 2. So this question requires a different approach for solving. So first, you have to find out the time periods for both the cases. Second, relate time period with magnetic field as the inverse proportionality of the square root. Then you simplify it, solve it for the new case where when you interchange it, you have to understand that the new magnetic field will be the subtraction, the difference of horizontal magnetic field and the applied field. So you subtract and then simplify the ratio, you will get x equal to under root 63. So that's how you solve this particular question. Okay. So you guys have to practice it. So I hope it's clear. So as I'm showing it to you, new formulas when we are encountering, I tell you all the time, I repeat. So please make a note of this. Okay, so that it will be very useful. Suppose this type of question comes, you have to be you should be in a position to attempt it. Okay, fine. So with that, we'll move on to the next question. Here's the next question. Question number 22. Okay, so one of you can read the question and tell me what is the relation that is given here. Yes, so please tell me what are the given parameters in the question. Please go through it. Feel free to communicate. So what are we supposed to do in this question? Question number 22. You have a cell with some EMF, okay, which is constant, is connected to a resistance R1 and then connected to a resistance R2. Okay, if power delivered in both the cases is equal, then the internal resistance of the cell. So then they are asking you what will be the value of the internal resistance if you are connecting both of them in, if the power delivered for both of them are going to be equal. That is the situation. So that is a condition that they've given. So based on this condition, we will have to solve this question. Okay. So for this, what I will do, I'll just erase this because I need some working space. So I hope you guys have made a note of this working that I've done. I'll erase this. All right. So here you have a cell. So they are asking us what is going to be the internal resistance if the power delivered in both the cases are going to be equal. Now, who can tell me what is the formula for power delivered or power dissipated? What's the formula? Dissipation of power or power delivered? P is equal to anybody? There are three formulas for power. P is equal to VI, I square R, V square upon R. Right? There are three formulas. Out of this, which one should we choose?
I squared upon R.
I squared upon R. It's I squared R. That's it. Okay. I square R is right. So we will choose the formula I square into R. Okay. That's the formula for power delivered or power dissipated. Okay. I squared R is the formula. Good. So we make use of this particular relationship. Okay. Now, what is the formula for current in Ohm's law? We all know that P is equal to I square R. What is the formula for I according to Ohm's law? V is equal to IR. So what is I? I is equal to P upon R, right? Here they are talking about EMF. When you say EMF, we can substitute the value instead of V, we will write it as E. Both are same. Okay, so it's E upon, now R. R is nothing but the total resistance of the cell. Now when cell is connected to a resistance, so what will be the total resistance? It will be total capital R plus small r, which is the internal resistance of your cell or battery. So that is the value of I. So you go and substitute this in the power formula. So what happens to the power formula now? So you will get P is equal to I squared, which is E upon R plus R. That is total resistance and internal resistance addition whole squared times R. Okay. So this is the formula. Now, according to the question, they're telling the power delivered in both the cases are going to be equal, which means P1 is equal to P2. So that is the condition. So if P1 is equal to P2, so let me write down. So P1, how do I express the value for P1? I can say because EMF is same, I keep the term EMF as E. upon R1 plus R internal resistance of the cell, the whole square times R1 is equal to E times the second another resistance they are connecting. Can you see? It is R2. So I am writing it as R2 plus internal resistance is same because it is the same cell that is being used, whole square times R. I hope this step is clear to all of you. Okay, we are equating the power. So when you equate the power, what are the terms that get cancelled off? Here, the EMF terms will get cancelled off, right? That will get cancelled off. And then what happens after the EMF terms get cancelled? You will get R1, here is there, times R2 plus small r, the whole squared, is equal to R2 times R1 plus small r, the whole squared, right? Rearranging by cross multiplication. Now you will have to simplify this further. So next what happens? Expand the terms, simplify the terms. Okay, go for an expansion, children. Expand the LHS term. Who can tell me the expansion of LHS and then simplification? So it's R1 times A plus B the whole squared. You do it. R2 squared plus small r squared plus 2 R2 times R equals R1 times the same way you expand it. I mean R2 times R1 squared plus small r squared plus 2 R1 small r. Okay, that's it. Now here, what can I take it as common? You can see that small r square is there on both the sides of the equation. So let me take small r to one side. Okay, so when I take it, I can take it as common out. So I'll get R1 minus R2 times R squared within brackets because that is common is equal to, on the right hand side, we can again simplify it. So when you simplify that term, what happens to the right hand side? You will get R1 times R2 within brackets R1 minus R. Okay, so I have simplified it. You can see on both the sides of the equation, R1 minus R2 is common, so I'm cancelling it off. So you can write R squared equals to R1 R2. So what is small r? It is under root R1 R2, and that's your answer. So that answer is option 1. Is it clear, children? So this is how you will solve this question. Okay. So the first and foremost thing is only relating the concepts. When you relate it, then mathematically you simplifying and solving should be an easy job. Okay, that should not be hectic. But how to relate and then simplify? So mainly relating is where you should be very careful. Okay, so for this question, the answer is the first one. I hope it's clear to all of you. So with that, we'll move on to the next question. Right? I hope this part is done. We'll move on. Okay, here comes the next question. It's question number 23. Okay, it's a different one. So let's look at it. Let's try to understand. A length of wire carries a steady current, is bent first to form a plain circular coil of one turn. Same length, now bent more sharply, is given 5 turns of smaller radius magnetic field becomes. So 5 turns of smaller radius, then what will happen to the magnetic field is what is the question. Okay, so here it's quite simple. The way they have asked seems, it may seem complicated, but it is very, it's a simple knowledge. What are they saying here? They're telling you that the length of the wire is first, it is bent in the form of a circle of just one turn. The length is same. And again, they are bending without compromising the length, just the radius is being reduced and 5 turns are being made. Okay, then they're asking you what is the magnetic field then after it has been bent into small. Okay, so here there is an important relationship that we use to solve this question. The simple relationship is B equals B naught times n square. This is an relation that we use. It's an important relation. Okay, so B is nothing but the magnetic field even before changing or altering the configuration of the conductor. B naught is the magnetic field after you alter it, after it is being altered. Okay, so B is the final magnetic field and B naught is the initial magnetic field. So we try to find out what is the final magnetic field in this particular case, just B. So go and substitute the values. Here they're telling you that 5 turns are being given, so n is going to be 5. So what is the answer? 5 squared is 25. So it is 25 times P naught. Your new magnetic field is 25 times the old magnetic field. So what is the answer? The answer is 25 times, which is option B, second option. Alright. So when you give it 5 more turns, as the number of turns increases, magnetic field will also increase. So that is the concept that is involved here in this question. Alright. So as the number of turns increases, so does the magnetic field of the conductor. Is it clear? Okay, that's the analogy. So we'll move on to the next question. So here's the next question. So here in this question, they have given you a loop P, Q, R, and S. Okay, the loop is given, and they have given you the forces that are acting along the sides of the loop as shown in the figure. Okay, so they have given you the forces. So you will have to find out what is the force on segment QP. So on QP, what is going to be the force? Then you will have to find out that force. Well, the force on segments PS, SR, and RQ are being given as F1, F2, and F3, which are 5, 4, and 8 newtons respectively. So our agenda is to find out what is the force on the other segment, which is QP. Now, what is the concept that is involved here? Now, they're telling it is being placed in uniform magnetic fields. This gives us some information. When they say a loop, a closed loop is placed in uniform magnetic field, you need to understand that that corresponding loop is going to be in equilibrium. Meaning, the resultant magnetic force on that current carrying loop is always going to be zero. So the resultant magnetic field is zero. What does that literally mean? It means Fr, modulus of Fr is going to be zero. You get me? So what is modulus of Fr? I'm going to expand this term, which means the force is due to each and every component. Okay, each and every segments rather in this particular loop, which is force due to the first segment. Let me take it as F1. That's already given there. Force due to the second segment is given as F2. Third segment is F3. Fourth segment we don't know. I will take it as FPQ. So this is equal to 0. Okay, PQ or QP anyways. Fine. So having this information, we will have to solve. So what is the force acting on PQ? How do we do that? Because the sum is 0. So what can we do? You know that force is a vector quantity, right? Because it's a vector quantity, you can see F1 is acting towards the left. So what will be the sign convention? So modulus I'm using, no doubt. So modulus of minus F1. F3 is acting right side. Okay. So plus F3. F2 is also acting. So you can see that it is acting vertically. So F2, the whole modulus, yes. So the whole modulus I'm applying. Okay. So this is the total term that we are having. So now to find out the resultant of the vectors, so we can take under root. So generally when you write resultant of the vectors, so under root of F3 minus F1. Okay, so F3 minus F1, because both are acting along the same axis. I mean directions, opposite directions, but the axis you can see the same axis only is. So F3 minus F1 the whole squared plus F2 squared. Okay, plus F2 squared. That's it. Substitute it, children, and simplify. F3 minus F1. F3 is given as 8. So 8 minus F1, which is 5. 8 minus 5, 3. 3 squared plus F2 is 4 squared. So root of 3 squared plus 4 squared. What is the value? I think it's a Pythagorean triplet, right? So we would get 5. So FPQ is equal to 5 newtons. So the answer is 5 newtons. So the answer is option 2. Okay. I hope this question is now clear how it needs to be solved. The solving approach is very important. Okay. So look at the figure. Based on the figure, we have now understood that the main concept is the resultant of all the forces due to the components of segments acting as it should be equal to 0. Rearrange and apply the parallelogram law of vector. So here it is very similar to the parallelogram law, the way it is being shown. Okay, that is the logic we are applying. Okay, so you may be asking, why am I not writing 2 pq cos theta term, right? Some of you might be having a doubt. Why are we not writing 2 pq cos theta? We will not write because the angle between the vectors is anyways going to be 0 degrees, right? So cos 0 is cos 0 or it is 90 degrees. So you should be careful. So here we are not really sure for the second component. 1 and 3 is fine, they are opposite, so simple subtraction we do. But for the third component and the fourth component, which we will have to find, so the angle between each one of them is going to be negligible. Negligible in the sense the angle between them is going to be cancelled out the way we are expressing them. So the way it is being expressed, so the angle cancels out for the other. So we just write F2 square, that's it. So 2pq cos theta term is negligible. So we don't consider the term in this case. That's the reason it's 3 squared plus 4 squared, which directly gives you 5 newtons. So we don't have that 2pq cos theta term coming into picture. Okay, so that is the analogy. So with that, so we move on to the next question. I hope this part is now clear. So moving on to the next question. Okay, question number 25. So here, question number 25, you can see two metallic spheres of radii. Radii is basically, the plural form of radius. Okay, so two metallic spheres of radii R1 and R2 are connected by a thin wire. So you connect two spheres. So we try to understand just by a simple diagram. So two metallic spheres of radius. This is having R1, the other one is having R2. You connect it by a thin wire. So charge plus Q1 and Q2 are on both the spheres. So first one is plus Q1 and the second plus Q2. Okay. These are the charges. Then which of the relations are true? Okay. So whenever a charge is given to a sphere, conducting metallic sphere, what is the formula or what relates potential, charge and radius? Anybody knows? What is the potential on a charged metallic sphere? From electric field and charges, you should be knowing the potential is given by V is equal to KQ upon R, right? That is a formula where K is your constant, isn't it? And Q is the charge that you're talking about, right? Here, this is the relationship. So K is anyways going to be a constant, isn't it? So we go for a simple rearrangement. So what is Q, children, rather? So Q is equal to V times R upon K. I'm just rearranging. Okay. So V is potential and K is constant. So entirely this term is going to be constant. V by K. So because the system is going to be in equilibrium, so this will be constant. The ratio of V upon K will be constant. Potential is same and K is also constant. Then what is Q1 upon Q2? So we understand that Q is directly proportional to R. Then what is Q1 by Q2? Q1 by Q2 is just R1 upon R2. That's it. The correct option is option 2 or option B. Find a simple one. Okay, so that's how you solve this particular question. Am I clear, children? So this is how you approach this question. Fine. So I'm taking time and I'm explaining each one of them. I hope you guys are making a note in case things are different and you feel that it's a new concept or it's a new formula. Please do make a note. Okay, and I'll be sharing this at the end of the day. All right. So with this we are done with this question. So we'll move on to the next question. Okay, question number 26. Fine. So here in this question you can see that there are two wire of length L1 and L2 carries equal current. Two circular loop made by these wires, then the ratio of their magnetic moment is 3 is to 2. So when two circular loops are being made by these wires of length L1 and L2, they tell you that ratio of their magnetic moment is 3 is to 2. Okay, it becomes 3 is to 2. So then they're asking you the length ratio of the wires. Okay, length ratio in the sense L1 is to L2. You should find out what is L1 is to L2. That's the question. So how do you approach this question? Here they have given you some data. 3 is to 2 is given. What is the meaning? Magnetic moment ratio, which is M1 by M2. So M1 upon M2 is 3 by 2. So that is what they have given. Right? What is the formula, children, for magnetic moment of a current carrying circular loop? There is a formula for that. Okay? The magnetic moment is given by the formula M is equal to I times A. That's a general formula. Okay. If we say it as NIA because it is just a circular loop and you don't have they have not told you the number of loops. It's just so we assume it's just going to be one particular loop. So therefore it is I into B, where I is current in amperes and A is area of cross section. So this 3 by 2 can be written as I times A1 divided by I times A2. Is it clear? A1 is the area of the loop having magnetic moment M1. A2 is the area of the loop having magnetic moment M2. Okay? Because they told current is equal, current terms get cancelled off. We can simply relate this as with the areas. So we can relate it with the corresponding areas. What is the formula for area of the loop? Well, pi r square is the area, right? Circular loop in the sense you would just tell it as pi r square. Okay, that's it. But when they ask you what is the length, so in terms of length, you can try to express. So pi r squared, so I will write it first and show. So 3 by 2 is equal to pi r1 squared and pi r2 squared. So pi would get cancelled off and you can simply write 3 upon 2 is equal to r1 upon r2 the whole squared. Right? We can write it like this. But they're asking us length. How can we relate length, children? How do you bring in the relation for length? What is the formula that relates length and radius of a circle? Anybody? Circumference of the circle can be related to radius, isn't it? So circumference is nothing but the length. So L is equal to 2 pi r. So L1 is equal to 2 pi r1 and L2 is equal to 2 pi r. Using this relation, I can go and substitute. Okay, you can see that length is directly proportional to the radius, right? So we can directly write m1 upon m2 equals to L1 upon L2 the whole squared. We just want L and L1 and L2, not L1 upon L2 the whole square. So take square root on both sides. You will get L1 upon L2 is equal to under root M1 upon M2. And what is its value? It is under root of 3 upon 2, which is root 3 upon root 2. And that's your answer. So root 3 is to root 2 is the answer. So the answer is option 3. Third option. Is it clear, children? This is how you solve this particular question. Okay. I hope this part is also clear. This question, the way we have solved. Okay, any particular doubts you can ask. Okay, anywhere you're stuck also you can please let me know. Okay, I hope you guys have understood this. So with that, we'll move on to the next question. Okay, so just go through it. Right, so moving on. Question number 35. So the next question. We have another question now today. So we'll see this question as well. So here, what is the given data? Again, we try to read the question. So read it and you will have to understand what's the given data. The number density of free electrons in a copper conductor is being given as 8.5 into 10 to the power 28. Okay, it's not clearly visible, but I'm telling you it is 10 power 28. Okay, meter cube inverse. That there. How long does an electron take to drift? They're telling how long does the electron take to drift? How long means they are. What do you mean by how long? They are asking you the time. Okay, so how much time does the electron take to drift from one end of the wire of 3 meter length, that is L is 3 meters, to its other end? They have given you the area of cross section and the current also is being given. Okay, so this is to do with drift velocity formula. So which is a formula that relates drift velocity, current, area of cross section, number of electrons. Okay, there is a formula that relates all of these, which tells, yeah, somebody is trying to tell, you can tell me. I equal to, yeah,
NEVDT, sir.
yes, I equals N E A V D, where N is the number of electrons, A area of cross section, V D is the drift velocity. Okay, this is the formula. Now, if I'm going to rearrange for, say, the drift velocity term, so what do I get? I can write drift velocity VD equals, because current is 1 ampere, so I can write it as 1 on NEA. Okay, so VD is nothing but 1 upon NEA. Fine. Now, what is the time? When I can write down the time in terms of velocity, yes, I can. Time is nothing but length or the distance traveled upon speed, right? Because you know that this speed is distance traveled upon time. Using that relation, T is L upon V, which is L times. So here you go for a rearrangement, children. Okay. So when you go for a rearrangement, so we can write this as, this is I, children, not 1. Okay, because when I rearrange it's current, right? So current is not 1 here, it's 3. Okay, so keep it in terms of current itself. So L times in terms of pi VD, so take the reciprocal of the previous relation, so you get NEA upon I, right? This is what you get for the time. Now you should go and substitute the values that we have. What is the length value given in the question? Length is 3, so 3 times number of electrons. Okay, so they have given you the number of free electrons also, so 8.5 into 10 power 28. Area of cross section 2 into 10 power minus 6 divided by current. Current is nothing but 3 amperes. Okay, 3. So this 3 and this 3 will get cancelled off. So you just need to multiply, children, and then simplify it. Okay. So go for the simplification and tell me what is the value that you're getting. Here you have to also include E. What is E? N only I have substituted. Please remember, E value I have not yet substituted. What is E means? E is nothing but charge of electron, that also to be substituted, right? So numerator, that also. What is the charge of electron? 1.6 into 10 power minus 19 coulombs, right? So that also to be substituted. So totally you will have 8.5 into 10 power 28. After simplifying, after cancelling the 3, what are the terms left out? I'm writing. Okay, into charge is 1.6 into 10 power minus 19 times 2 into 10 power minus 6. Okay, this you simplify, children. 28 minus 19 minus 6. How much will you get? Oh, simplification part you will have to do it. 28 minus 19. How much is that? 9, right? 9 minus 6. 3, isn't it? So into 10 power 3. Overall is 10 power 3. 8.5 times 1.6 times 2. So 8.5 times 1.6. 85 by 10, and that is 85 into 16 upon 100, right? So simplify it. 68 upon 5 you will get, right? 68 by 5. Okay, don't forget there is 1 2 also. Okay, so how much will you get? 68 into 2, 136 upon 5 into 10 power 3. How much is 136 upon 5? You should divide it.
27.2, sir.
Yeah, so 27.2 into 10 power 6. I mean 10 power 3, sorry. So the decimal place you will write it in significant figures. That means you will move this decimal place to the left. If you shift it, what will happen, children? 2.72 into 10 to the power. If you shift the decimal place to the left, I hope you guys know you will increase the power, right? So the power to be increased or decreased. So this and all you should be knowing. So when you shift the decimal to the left, yeah, increase or decreases. 10 power 2 or 10 power 3? I mean 10 power 4. Is it 2 or is it 4? 4?
4.
Okay. So, okay, so appropriately you write it. Okay, 10 power 4 seconds. Alright. So do that, children. Once you have done it, you will get your answer. Okay. So that's the answer. So like this, you will have to solve and find out the answer for this question. Okay. So this method, I hope it's clear. So appropriately, that option you should take. Okay. So first one. All right. So the powers, carefully you calculate it and then you find out the final answer. Okay. So 28 we did minus 19. Let me also check. Minus 6. Okay. Yeah. So the answer is option A, or the first option. Okay, so this one again the formula for drift velocity, how we are rearranging, in terms of time, and then substituting the values and going for a simplification. Okay, is it clear, children? Any doubt in this question? I hope this is clear to all of you. If you have any query, you can ask. I will move to the next one. This is what I loaded for today. Anyways, we have finished it fast. Okay, so we will go to the next question. I'll bring the next question and I have to write it on the screen. So meanwhile, you can go through it. Anywhere you're stuck, also you can ask. Let's see, different model. Okay, we'll go to the next question. Okay, I'll just show a writing pad. I hope the writing pad is visible to all of you. It's a black screen. I hope you guys are able to see it. I switched on to a different pad now. Okay, I mean a different tab. Okay, I hope you guys are able to see it. So the questions I will write it here now. The continuation. The questions we will see here. So we move on to the next question. Okay. What's the previous question number? Okay, we are going to fine. So next question. So I'll write it here, children, and go through the question. A rod of length L, capital L, okay, has a total charge. A rod of length capital L has a total charge Q distributed distributed uniformly along its length. Uniformly along its length. Okay. It is bent. It is bent in the shape of a semicircle. It is bent in the shape of a semicircle. Find the magnitude. Okay. Find the magnitude of the electric field. Find the magnitude of electric field at the center of curvature at the center of curvature of the semicircle. Okay, at the center of curvature of the semicircle. So options are, I'll give you the options. Option A, Q upon 2 epsilon naught L squared. Option B, Q upon epsilon naught L squared. Option C, 2Q upon epsilon naught L squared. And option D, 0. Okay, these are the options. Fine. So you have a rod. The rod of length L is being bent in the shape of a semicircle, and there is a charge Q that is distributed. So as per the question, you need to understand the length of the rod is L. That's given data. Charge is Q, children, and it is being bent in the form of a semicircle. Okay. They're asking us the electric field at the center of curvature of the semicircle. So first, let's try to draw this figure, and let's analyze it further. Okay, so when you bend the rod in the shape of a semicircle, so it takes this shape. So, in the shape of a semicircle approximately. So, I'm drawing. So, I'm doing a freehand drawing, so don't mind. Okay, so this looks like a semicircle. So this is bent in the form of the rod which was straight is now bent. Okay. Now what is the radius? This is the center of the semicircle. Let me call the center as O. This is the radius. Fine. This is the radius of the semicircle. Let the radius be R. Alright. The length of the semicircle is L. That is the length. Having this information, so we are trying to find out what is the electric field. Now you all know that whenever you have a straight line of charge, it is associated with linear charge distribution, and linear charge density is associated, which is given by lambda. So we are going to use that particular relationship. Okay, so the formula here is given by, the electric field formula is given by E is equal to 2k lambda upon r, where r is nothing but here the radius, the radial length, because with respect to the sector we are trying to find out. Okay, so 2k lambda upon r, where lambda is nothing but the linear charge density. Okay, now you all know that k is equal to 4, 1 by 4 pi epsilon naught, right? So we you know that relationship. So we are further simplifying here, and lambda is nothing but the linear charge density. Okay, so that is what we are trying to use. So substituting all that particular relationships, so we can write 2 K also I'm substituting 1 by 4 pi epsilon naught. So 4 pi epsilon naught into radial length in terms of the length of the semicircle can be expressed. So linear charge density lambda. So I'm going to expand that also and write. So we can write it as L squared, which is L squared divided by pi. Okay. So you know the entire semicircle is 2 pi r, but here basically we only have half of it. So when I say the linear charge density, it is the density per unit length. That is why I'm putting L. Okay, and density is mass times volume. So here directly we are substituting the value for the bent form of the wire. So we get it as L square upon pi. So go for the simplification here, and not to forget charge per unit length. So it is Q. You should not forget to put Q. Okay, because charge per unit length of the corresponding wire that is being bent. Okay, so Q divided by corresponding length L. So again I'm substituting the values and go for a simplification. So you will get E is equal to, so here this 2 and 4 can get cancelled off. So you will get Q upon 2 epsilon naught and L square. Pi is also getting cancelled. Okay, so L is, here we are using capital L, we can put capital L. So Q upon 2 epsilon naught capital L squared. So I in terms of capital. That's it. Alright, simple as that. So that is what we are doing. Okay, so the option here Q upon 2 epsilon naught L squared. So option 1 or option A in this case. The first answer is correct. So like this you will have to solve this particular question. Okay, so this methodology is very important. Okay, so charge per unit length, I hope all of you know it, how to go and substitute charge per unit length. Okay, next radius in terms of length and pi is what they are written, right? I hope that everybody knows. Total circumferential length is anyways going to be here. It is only half the circumference, so it will not be 2 pi r, right? So L is equal to pi r, isn't it? So what is r, children? R is L by pi, right? That's how that L by pi came. Okay, and got multiplied with the length which was already there, because lambda is equal to Q by L. Fine. So that is understood. So don't blink how sir directly wrote L squared by pi. Fine. So Q by L is there, and then R, that is radius, is being substituted as L by pi. That's how the term L squared by pi came into picture. Okay, in case you didn't get the correct, so I'm telling you how it came. Fine. That's all about it, children. So this is how you solve this question. So we'll go to the next one. Let's see one more before we wind up. So let's see the next question. Okay, here comes the next question. So you write it down. In the figure, in the figure, three capacitors C1, C2, and C3 are joined. Okay, are joined to a battery. Okay, they join to the battery. So the correct condition will be, so what is the correct condition they are asking. So I'll give you the figure. Let me draw it. Here comes the figure. So So each and every capacitor, they are given the values. This is V1, C1, and this is Q1, V2, C2, and Q2. This is V3, C3, and Q2. And this is V. This is a figure. Okay. Based on this options. First one, option A. Q1 is equal to Q2 equal to Q3, and V1 is equal to V2 is equal to V3 is equal to V. First option. Option B, again charges Q1, all the charges, first charge is equal to the sum of the other two charges. So Q1 is equal to Q2 plus Q3, and V is equal to V1 plus V2 plus V3. Second option. Okay, third option, option C. So the first charge Q1 is equal to sum of both, and V equals this V1 plus V2. And last option, Q2 is equal to Q3, and V2 is equal to V3. These are the options. Okay, so they ask you what are the correct relationships. For this, you have to first analyze what is a circuit combination. Combination of capacitors, right? So, what is a particular combination? Let us try to understand the combination. Okay. First capacitor C1, second capacitor C2, and third capacitor C3. Now, when capacitors are in parallel, what are same and what is different? So you should understand that first. Okay. So the total capacitance here is going to be C effective, and first capacitor is C1. Okay. Capacitors 2 and 3 are in parallel. Okay. So you can write this as C1 plus C2 parallel with C3. If C2 and C3 are in parallel, something is similar between both of them, right? What is similar? What is same and what is different for C2 and C3 for second and third capacitor? Whenever capacitors are in parallel, what is same? Yes? Any idea? Potential is same or charge is same? What is same? Yes, that's correct. Potential is same, right? So you can say V2 is equal to V3. That is absolutely correct because both of them are in parallel. The potentials across each capacitor will be same. Okay, but what about the charges for each capacitor in parallel combination? Okay, charges are different. So therefore, the total charge, if you talk about the total charge in this system, it will be, you can say Q1, charge Q1 is equal to sum of both the charges, which is Q2 plus Q3, because both of them are in parallel here. So it is Q2 plus Q3, the total charge for this entire, the two capacitors which are in parallel. So the Q1 equals Q2 plus Q3. What about the overall potential? Potential V. It is, the potential is V1 plus V2. We need not add V3. Why? Because V2 and V3 both are same. So you should not add them. Are you getting me? So therefore V equals V1 plus V2. So which of the options are really correct here? Based on the relations that we wrote. Option A, B, C, or D. Which option is satisfying all the conditions for this question? The potentials of second and third capacitors equal. So V2 is equal to V3. So where do you have V2 equal to V3? Third option, right? First option also you have, but it is equal to total overall, potential they have told, right? So third one, V is equal to V1 plus V2. Yes. Q1 is equal to Q2 plus Q3. Yes, that is also correct. So option C is most correct, most appropriate, right? So the answer is option C in this case. Okay, so go with the relations and then see which of the relations are true based on what you have deduced. Okay, so deduce the relations between the capacitors and potential and charges and then simplify. All right, that's all about this particular question. Okay, so still we can do many questions, but it's almost done for today. So any doubts, children, you can please let me know. Okay, based on today's lecture, I hope we have seen different varieties of questions from different aspects. Okay, the same way we will do it. So we will cover many questions as possible. So you will have an idea of how to approach them and solve them as well. Okay, so any doubts, that is open. Please feel free to ask doubts. Okay, in case you are stuck anywhere. All right, so make use of us. We are always there to help you. All right. Yes, children. So anybody's got any doubts, you are free to ask based on all the questions that we saw. Otherwise, we can wind up. Yes, children. Sudarshan, Purunjada, all the questions I hope you have understood. Anywhere you have a doubt,
Understood, sir.
you understood. Good. Okay. So feel free. Only one or two students, talk. I want everybody, to communicate actively. Okay. So it's good to talk, children, whenever get an opportunity to speak. Okay. So make use of it. Don't feel shy, in asking how any doubts. Okay, so your doubt can be not it's not only your doubt, it can be someone else's doubt also, so it will definitely help out other kids. Okay, feel free. So done, so shall we wind up? Okay, if you're done we can wind up then. All right, so please go through it. Formulas also, I would expect each one of you to maintain separate formula book. Chapter wise, if you can write, it will be really great. Okay, so formulas should be fingertips because maximum numericals will come in physics. So formulas have to be in your fingertips, and then you can look at theoretical aspects. But first, I would definitely recommend master all the formulas in all chapters. Okay, so that's the main aspect. So once you have done it, then you can proceed. So how to remember formulas? Many children ask me. Okay, so the different ways, children. So you have mind maps, we have flashcards. Okay, so it all depends on what you feel comfortable. So in our times, we didn't have mind maps and flashcards. I used to maintain a separate notebook for that. Whenever I encounter new formula, I write it down in that notebook against that chapter. So each and every chapter, 5 or 6 pages, I leave at random and write the chapter names and keep. So as and when the chapter is finished, the formulas are written in the order. So that way, it is very useful for me. That I felt that was easier for me. For you, it might be different, method approach. Okay. So flashcard, mind maps will definitely help. Okay. So try to write the formulas without seeing chapter wise, and then you can check it with the notebooks or with the notes. So that way you can, self-evaluate. You can check yourself. If you're done wrong, you can correct it. So that way, you can avoid making errors in remembering the formulas. Okay. So you can enhance your retention capability by doing it. So one time writing is equal to 100 times reading. So you write it without seeing, that is definitely going to stay in your mind for a long period of time. Please do that. Okay, and questions what we have solved also, try to solve it, children. The same question you solve it without seeing, you can itself, that itself will help you. I'm telling you, that will boost your confidence level. Okay, so it might seem simple, when I'm explaining, I do it step by step. So you will think, okay, yeah, we have understood this, it's easy. But only if you are going to do it without, anybody's assistance or guidance, you will know where you are going wrong. So self introspection is very important. So if you're able to do that, self-evaluate and you're able to correct your errors, so your job is done. So that way you can improve. Okay. So these tips, will definitely help you to ace out the exam fear. So start off, now itself. When is the exam? Your NEET 2024 examination. Anybody knows the date? You should have seen and you guys have applied. So when is the date, children? 5th. Okay. 5th of May. 5th of May for everybody, is it? Because here elections are coming in the month of May. Oh, yeah, yeah, yeah. Okay. I think here it is postponed in Maharashtra region. We have by-elections coming in. Because I got a message saying that it is on June 26th or 27th. We don't know. I hope they have not updated in the NTA website yet. Okay, fine. Okay, so start, prepare children. Okay, every day, don't waste your time. So make a timetable. You have ample amount of time. Okay, fine. Yeah, one of you saying April 5. Okay, J. All right. Yeah, all the best. Do it your best, Sean. Okay, fine, children. So let us meet up in the next lecture. Okay, until then, bye bye. Take care and all the best for your upcoming examinations. All right. Yeah. Okay, children. Bye bye. Yeah. Welcome.
Thank you, sir.
Welcome, children. Welcome, ma'am.
Thank you.
Yeah.
Thank you, sir.
Welcome.
Thank you, sir.
Welcome.